Hello students, welcome to the subject of complex variable and partial differential equation. This is Dr. Ankit Acharya, and as you all know that in last lecture we discussed about how to find particular integral for case 2. And what is my case 2? Case 2 is nothing but function f of xy is nothing but sin ax plus by or cos ax plus by. So as you all know that in this case, instead of d square we have to take minus a square, instead of d into d dash we have to take minus ab, and instead of d dash square we have to take minus b square. Okay, and we already solved two examples in last lecture. This is our first example, if you remember, and this is our second example. Okay, d square minus 2 d dash z, that is equal to sin x into cos 2y. Okay, let's solve one more example. So del square z by del x square minus del square z by del x del y, that is equal to cos x into cos 2y. So first of all, I convert this function in this form. As you all know that I just multiply with 2 and divide it by 2. So this is 2 cos x into cos 2y. So that can be written as 1 by 2 cos x plus 2y. Okay, cos x plus 2y plus cos x minus 2y. Okay, now we have to first find complementary function. So that's why, what is my f of d dash? F of d dash, that is equal to d square minus d dash, that is equal to 0. Now when I convert this equation in m form, so this is nothing but m square minus m, that is equal to 0. And what is my m? M is nothing but d by d dash, right? So m into m minus 1, that is equal to 0. So what are the roots? Roots are 0 and 1. Okay, roots are nothing but 0 and 1. Complementary function, that is equal to f1 y plus f2 y plus x. Now I want to find particular integral. So we know that particular integral is nothing but 1 upon f of d dash. So 1 upon, what is my function? Function is d square minus d dash. Okay, so 1 upon d square minus d dash, and function is 1 by 2 cos x plus 2y plus cos x minus 2y. So we have to operate separately. 1 by 2 cos x plus 2y plus 1 by 2 1 upon d square minus d into d dash cos x minus 2y. Now you can understand. See, for x plus 2y, instead of d square we have to take minus a square. So that means what? Instead of d square we have to take minus 1, and instead of d into d dash we have to take minus ab. So that means instead of d into d dash we have to take minus a into b, that means minus 2. So that's why this equal to, I can write 1 by 2, instead of d square I have to take minus 1 because minus a square, minus, instead of d into d dash I have to take minus ab. So minus 1 into 2. Okay, so that is equal to minus 2, right? Cos x plus 2y, and here plus 1 by 2 plus, I can write here plus 1 by 2 1 upon, what is this? Instead of d square here we have to take minus 1, so minus 1 minus, instead of d into d dash we have to take minus ab. So what is minus ab? The value of minus ab is minus 1 into minus 2, so that will become 2. So that's why here we have 2 cos x minus 2y. So that's why our final answer is C. This is minus 1 plus 2. Okay, so that is 1. So 1 by 2 cos x plus 2y, 1 by 2 cos x plus 2y, and this term is C. In denominator here minus 3. So minus 3 into 2. So that's why minus 6 minus 1 by 6 cos x minus 2y. Okay, so, and general solution, as you all know that general solution is nothing but complementary function plus particular integral. So just write down in each and every example, general solution z is equal to complementary function plus particular integral. So in this example, what is your general solution? General solution is nothing but f1y plus f2y plus x, which is my complementary function, and plus 1 by 2 cos x plus 2y minus 1 by 6 cos x minus 2y. Okay. So let's solve one more example. So next example is this: 2 del square z by del x square minus 5 del square z by del x del y plus 2 del square z by del y square, that is equal to 5 sine 2x plus y. So first of all, we find complementary function. As you all know that what is f of d d dash? F of d d dash, that is equal to 2 d square minus 5 d into d dash plus 2 d dash square, that is equal to 0, right? Now the function of m, that is 2m square minus 5m plus 2, that is equal to 0. Okay, and when we factorize this polynomial, second degree polynomial, we can write 2m square minus 4m, because 2 into 2 4, right? And here middle term is minus 5m, so we can factorize in this manner: minus 4m minus m plus 2, that is equal to 0. Now from this first two term, 2m will be common, so in bracket now we have m minus 2. From third and fourth term, minus 1 will be common, so in bracket we have m minus 2, that is equal to 0. So that's why 2m minus 1 and m minus 2 equal to 0 are our factorization. So roots are 1 by 2 and 2. Okay. So what is my complementary function? Complementary function, that is equal to f1 y plus x by 2 plus f2 y plus 2x. Okay. And to find particular integral, we know that particular integral is nothing but 1 upon f of d d dash into f of xy, and f of xy is here 5 sine 2x plus y, and f of d d dash is nothing but 2d square minus 5 d d dash plus 2 d dash square. So first of all, I write f of d d dash, that is equal to, so particular integral, that is equal to 1 upon f of d d dash, so that is 2d square minus 5 d into d dash plus 2 d dash square. And what is the function? Function is, let me show you. Okay, correct, f of d d dash I write, and function is 5 sine 2x plus y. So here I write 5 sine 2x plus y. Now as you all know that what is here a, compare with sine ax plus by. So a is equal to 2 and b is equal to 1, correct? A is equal to 2 and b is equal to 1. So instead of d square, we have to take minus a square. So that's why we have to take minus 4, right? Instead of d into d dash, we have to take minus ab, right? So that's why we have to take minus 2. And instead of d dash square, we have to take minus b square. So that's why we have to take minus 1. So when we take d square is equal to minus 4. So minus 4 into 2, minus 8. Instead of d dash square, when we take minus 1, so this last term become minus 2. Now try to remember, this is minus 8, minus 2, minus 10. And when we take d into d dash, that is equal to minus 2. So middle term become plus 10. Okay. So that's why denominator becomes 0. I hope you can understand. When we take all these three values, instead of d square, when you take minus 4, instead of d into d dash, when you take minus 2, and instead of d dash square, when you take minus 1, definitely your denominator becomes 0. So that's why we have to multiply with x, right? Okay, and differentiate this function with respect to d. So that's why that is 4d minus 5 d dash, and 5 is already there on numerator, so just write down I here 5 sine 2x plus y. Okay, now multiply with d and divided by d, so that's why we get, because only we can take the value of d square, d dash and d dash square. Instead of d and d dash, you cannot take any value. This is not a case 1, don't forget. Okay, So we multiply with d and divide it by d. So that's why now we have 4d square minus 5 d into d dash sine 2x plus y. Now you can apply the same rule. So that's why now we have, instead of d square we have minus 4. So 4 into minus 4, just I write here 4 into minus 4, okay, and minus 5 d into d dash. Instead of d into d dash I can take minus 2. So minus 2, okay, 5 is already there, right, and d sine 2x plus y, right. Now in denominator try to understand, this is minus 16 plus 10, okay, so minus 6, and on numerator already we have 5, so minus 5x by 6. I can write this equal to minus 5x by 6 d, capital D means differentiation with respect to x, sine 2x plus y. So sine 2x plus y, that means differentiation of sine 2x plus y with respect to x, okay, and that is cos 2x plus y into 2. So the final answer is minus 5x by 3 cos 2x plus y. Okay, so this is my final answer for this example for particular integral. And don't forget to write general solution. What is my general solution? Z is equal to complementary function plus particular integral. So f1 y plus x by 2 plus f2 y plus 2x minus 5x by 3 cos 2x plus y. This is my general solution. So in today's lecture we discuss about case 2. Either your function is sin ax plus by or cos ax plus by. For both the case, for both type of function, we apply the same rule. Same rule means what? Instead of d square, you have to take minus a square. Instead of d into d dash, you have to take minus ab. And instead of d dash square, you have to take minus b square. Right? In this example, you can understand that suppose in your denominator, just you have d or d dash, right? So you can multiply with d and divided by d. So now in denominator, now you have d square d dash, right? So instead of d square d dash, you can easily take the values, and on numerator, suppose you have d or d dash, it's quite easy because d into some function, that means differentiate of that function with respect to x. D dash into some function, that means differentiate of that function with respect to y. So after that you can easily differentiate and you can get the correct answer. So thank you.